Welcome back to our studio. I'm joined here by Lize Raes, who is a collaborator at LangChain4j and who loves inspiring developers with the use of AI in real-world applications. I've seen several of your talks and demos already, so I look forward to seeing what you have in store for us today. And also, as mentioned earlier in the talk with Sharat, you will be joining Oracle as a developer advocate in August. So congrats on the new job as well.
Thank you very much.
And well, take it away, I guess.
Okay, thank you, Marit. So I'm here today to show you the next level features of LangChain4j for enterprise-ready AI applications. LangChain4j turned 2 in May and also released its 1.0 stable version. So that's why we're talking about these next level features. But I know that probably quite some of you have not used LangChain4j in its basic version yet. So I'm going to do a quick dive into the basics. So I have you on board for the rest. So LangChain4j, what it's all about, it's to connect to large language models mostly. Via API. So you don't have to care about data and the ML ops cycle there. You don't have to be a data scientist to use AI in Java if you're just going to use the existing models. So we allow you to super easily connect to anything from OpenAI, the people behind ChatGPT, to Anthropic, Claude, Gemini, Azure, OpenAI, but also local things like Olama, local AI, JLama. If you want to see what we support, you can just go to our repository, which is github.com/langchain4j/langchain4j. And if you scroll down all the code there, you will see, for example, our popular LLM providers that we support, the local ones, the commercial ones, all the documentation is there, the examples are there, and I wanted to show you at least a Hello World example. So if you want to get started, go to this examples repository of LangChain4j, look into tutorials and just run through these. It's the fastest way to get started. So let me show you Hello World, what it's all about actually. It's just very easy to make an object for a chat language model, which in this case we use an OpenAI chat model. I'm going to set my key, I'm going to choose my model, and then I can start chatting with this. So we're going to say, running this, say hello IntelliJ and then see, it's not saying hello IntelliJ because it's an LLM. It's saying hello IntelliJ, how can I assist you today? So that's how easy LangChain4j makes it, and you can swap easily with all kinds of other models. Now, that's the basics. Turns out you can do a lot more cool things with LLMs, right? You can give them specific instructions to behave a certain way. You can hold a memory for them, which you have to do because the models are actually stateless. Then you can also get extra information that they were not trained on in their context. For example, your company documents or the weather you go query via some API. So this is what we call RAG. We're going to come back to it to get extra information to your LLM. And then my personal favorite, tool calling or function calling. When you tell the LLM it has tools or function available, it knows when to call them with which parameters, and then we're going to run the code for it, and then it can continue with that answer. So that's this basic LLM with everything around it, and I'm gonna show you some code. So the easiest way in LangChain4j to use this is to make an AI service. It's a bit of a magic concept, but you're gonna see how it works. So the first thing is you declare what you want, and let me show you that right in the code. That's gonna be more fun. So an AI service works like this. You declare an interface. Like this one has two methods, a translate method and a summarize method. And then you can take whatever parameters as input. So for example, translate will take in a text to translate and a language to translate to. And it has an output a string. But the nice thing about this is that you can have any Java object. A POJO, in this case, a list of strings, and your LLM will kind of return this. Behind the scenes, we do a lot of JSON parsing and everything, but what you get is a real Java object to work on with. Why is this cool? For example, my favorite little demo here, we're going to go over it very quickly, is date-time extractor, because I don't know if you like parsing date-time formats.
Not so much, no.
So that's why we made this one. I mean, it's a bit overkill to use an LLM for it, but it's very nice. So the text we're going to parse here is at noon, 3 days before Valentine's Day of 2025, Jane realized that John was more in love with his IDE than with her. And what we want to do, we want to extract a datetime object from that. So we use this one that we, in this interface, declared extract the datetime from. And we're going to really have a local datetime object. So let's try when we run this code. If it manages. There we go. So that's the 11th of February 2025 at 12 at noon. And we didn't have to do any thinking or parsing. So the way this works, this AI services, after you declare them, and you can specify a user message with instructions, you can also specify a system message with instructions. And a user message is kind of the thing you say as a user. You can add tools there very easily, memory, we'll see that later. And then you can do AI services.create or .build and build this whole thing up. And you don't really need to code what's going to happen there. It's going to be an LLM that takes care of doing it. Good. So for these basics that were the AI services, here's a little example where instead of local datetime, we're going to really return a Java object, like an electrical component data sheet with all kind of fields. If we want to give it specific tools, like to calculate power from voltage and current, whatever domain you're in this case, you can annotate them with tool, as you can see here. And here we declare our interface for our AI service, saying you provide the user with information about electronic components, like it's a general thing that applies for the whole conversation. And the two methods is a generate a data sheet for your electronic component, and it's going to give you some component data sheet object back, like we specified before, or like another like get manufacturer based on a component. So all these things you can puzzle together what you need. And then we do again like AI service.builder for this component info service interface that we declared, and we can add the model of our choice. We can add a content retriever which allow us to interact with the database here of the components. We'll show that in more detail later. And this is how you add these tools that we declared, and then we can start using it. And then I can say something to my AI service like generate datasheet method. I need a shift register with the last 8 parallel outputs. It will go look into the document it has. It will use those tools to do conversions, and it will give you a proper Java object back right there. All right, that's all the cool basic LangChain4j. What we're going to do today is we're going to dive into these next level features, which is a short touch on state machines and agents. Then we're going to look at advanced RAG, smarter ways of getting more context, multi-model architectures, if you want to call multiple models, and how you swap them, model context protocol, MCP, all the hype at the moment, so we're going to quickly touch on that, see how we integrate audio, guardrails and moderations, very important to have enterprise-ready things that are actually secure. And then observability, also again very important, and evaluations. How do you evaluate things that never output the same deterministic answer? That we're going to see too. Good. Let's dive right in. These are the 5 levels towards general artificial intelligence, and we thought I made this application for the demo together with Mohamed Ait Abderrahman, and we thought let's just aim high. Let's aim at AI that can create new innovations, because at some point we run out of training data or it gets really hard. What if AI could create its own new data or research actually? So we inspired for our app of how humans actually expand their knowledge, which is like, okay, we figure out something that we don't know yet. Then we see what we already know, adjacent things. So that would be search in the literature. Then we're going to design an experiment to see how can we find new information, what do we need to test. We run this experiment. We analyze, we pull a conclusion, and then we're going to publish this. And then it becomes part of a new, bigger amount of existing knowledge or literature. So that's what we built with all these steps, but we did it for drug discovery, specifically antibody drug discovery. So a very quick dive into that. What we are making here is basically we want to design antibodies that bind to specific diseases. So our body has these naturally, but some diseases like cancers typically they don't recognize well enough, or they don't recognize. When they do recognize, it looks a bit like this. They go bind on the disease cell, And once they bind, they're like, hey, this one it's a disease cell, we're up for destruction. And then come white blood cells or killer cells, and they get rid of this thing. So it's extremely specific. There's not many side effects, and it's using the body's own process to actually get rid of the disease. Here you see Staphylococcus aureus being eaten, for example, by one of our body's cells. I worked in bioinformatics for a while. I find this really fascinating. Now, the problem with these engineered antibodies is that they consist of many more atoms than these small molecule drugs that we usually know. So the one on the right is normal chemotherapy, and it has a lot of side effects. The other ones are better, but they're really hard to design. So once you design one, like the whole sequence basically, then you also have to test like how well does it bind to my disease? Isn't it toxic? Is it stable? Things like that. So we drilled it down to this, and the details don't matter much, but we're going to choose a disease to tackle. We're going to find what this disease look like. We're going to find already known things. Then we're going to find what the sequences are of the known things. Then we're going to propose a new one, test the new one, and publish an article. So all of these steps are part of like a much bigger research cycle that's already happening, but a lot of it's manually. So actually AI has the potential, if we have the right models, to design better fitting sequences, or also to steer the robotics in the lab to actually test this. Good. So one option to run through all these steps is to let the LLM take care of the state machine. And it's very cool. You just tell the LLM, run through all the steps. Here are all the tools. Here is all the information you can use. And if it's not too complex, it's going to do well. The nice thing is when the user says halfway, oh, sorry, I made a mistake, let's go back to step 2 or something, the LLM will deal with it. You don't have to program much either. It looks like this, actually. You give all the tools, you give all the documents it can use, and then you say, like, run through all these steps. But it's not very secure, and sometimes things will happen you did not intend. The other solution for this is to let the code manage the state machine and run the LLMs in these specific steps only. So then you can get very complex, but you have a bit more programming work. And below here is a diagram so you can understand why this sometimes is really important. This is a shopping assistant workflow, basically. And for example, you would want the user to verify the basket before the order is placed. If the LLM could place the order, you want to be sure that the basket is verified, and not hopefully the LLM will do indeed this step before. So if the code does that, the LLM cannot change the order. Some things like calculating a total price, I don't want an LLM to do that either. They're not made for that. So we just want code, right? So then you enforce that step in code. And then once you place the order, that's like with your credit card info and everything, maybe we want human confirmation out there, and not just say to the LLM, please ask the user for permission, because 90% of the time, yes, it will do, and 10% of the time it will just go ahead, right? If you enforce this human intervention here in the code, the LLM cannot get around it either. So that's the interesting part of the code state machine, and that's also what we did for our app. So I'm just gonna show how this conceptually works. Whenever a message comes in, depending on what step we're in, then we're gonna either call, for example, if we're in the define disease step here, we're gonna call the disease picker AI service that does only that. If we're in another step, we're gonna call the other one, and then the AI services themselves are gonna push us to the next step when they think we're ready in that step. We also keep state objects, of course, the step itself, and then the whole research project, which we're going to fill while we go through these steps. We're going to define a disease and solutions and how well they perform. So that's going to be filled out on the way. And then these AI services for the different steps, they look like this. They are very different in what they have to do. For example, our disease picker, this first step, which disease do we even want to treat? That's a bit sparring with your LLM, so it has memory because it's a chat. It has no RAG, so no external documents because you're just talking there. And it has the tools to store the disease name once you decided on it. And that's where the trick is to jump to the next step. Once you store the disease name here, so the LLM knows, like, once they're sure, we call store disease name. It's stored on our stateful object, and we're going to push our to the next step, which is find the antigen, find the disease cell, basically. Step 2 is very different. For example, this is just gonna output, let me look in the code, the disease name, and then afterwards the sequence. So it has tools to find the sequence. It has RAG, so it can look into the scientific literature that we give along, because it has to go search, but it has no memory because it's just has to do its task. It's not, I don't have to talk with it. Once it knows the disease name, it can go on and do this by himself. So that's how we built up these different AI services. Now, RAG, retrieval-augmented generation, used to be a way to just chunk documents into pieces and find the right pieces that fit your question and add them with your question, so the LLM knows, for example, the terms of services said something about how can we cancel, and the question was about canceling, so we're going to only add those chunks, and then the LLM knows about our specific terms of service. Now that worked a bit, but not great, so that's why we now have advanced RAG. Yeah, everybody that tried it knows it. So let me dive a bit technically in advanced RAG, because it's very important. And why is it important? For example, while we were developing the app, at some point in finding the sequence, it asks, shall we proceed to the next step where we find known antibodies for this target disease and their characteristics? I said, yes, please. And all of a sudden, I see here in the logs that it finds like, yes, please, is a book, a big juicy stew of personal stories. And I was like, like, did we get strange PDFs in our resources or something? But no, it did a web search with yes, please, which can be very undesirable, especially in production. So that's why, for example, you will want a query compressor, and I'm just gonna explain right away what that is. So once your question comes in, it's often part of a larger conversation. And when I say yes, please, I actually mean the question, give me the antibodies that work well on this disease or something, not just yes, please. So Query Transformer will take care of making my question into the real question. Compressing Query Transformer just makes one thing out of the whole memory that makes sense. And expanding Query Transformer will ask it in many different ways. So you're sure you have all these parts that you might want to need. So once your query is like clean or useful, now you can, with advanced RAG, send it to a query router that will decide to which of our content retrievers we go. So it used to be just a document content retriever, but now we support many more ways to retrieve content in LangChain4j, which is this embedding store. That's the original one for documents. Neo4j for graph RAG, as they call it, web search, and a SQL content retriever for any database where you want to get the information from. As you can see, these types of retrievers need very different types of queries, right? SQL or web search, it's very different, and your query router will also take care of that. How does it know where to send it to? Because we gave a little description in a map of which content retriever does what. Then, once we have all pieces from our content retrievers, all pieces of text that might have been relevant to our question, we're going to aggregate them. So we have a default aggregator that's just going to add them to our question, or a re-ranking content aggregator, which I would really say use it. It's going to check once more, hey, these parts that we found, are they actually relevant to the question we first asked? Because in the traditional RAG, very often they were not. And once you send an LLM something like, here's a question, and here's some piece of document that has nothing to do with it, it's gonna try to still use it in the answer. You even notice this in ChatGPT, right? When it goes fetch things and they were not relevant and it just keeps going on about them. So your re-ranker should cut these parts out so they never even make it to the LLM. That's advanced RAG. They are all interfaces, so if you want to make your own implementation, you can. All right, what it looks like in reality is like, for this app, we have 3 content retrievers. This one is an embedding store content retriever here that's gonna load our documents, split them, and so on. But then we're gonna put them to our map retriever to description. So here is the retriever for our literature, and here is its explanation, scientific literature on diseases, and so on and so on. And that's what the query router will use to know we should send it there or not. The web search content retriever looks like this. In this case, we are not adding it because we are working scientifically. We don't want it to go find random stuff on the web to solve our disease problem here. And then a SQL database content retriever, we also add it to the list. And then we make our retrieval augmenter, is it called, this whole thing that we looked at before. And there we see our query transformer at the beginning, the query router, that contains actually this map, content aggregator with a scoring model, and then like even how do you inject those messages into the question. I'm showing you all this code so you know this is doable. You find examples of all of this, and I will also share the link to this repository if you want to make your own version. Good. Something else we're going to run into later is that we may want to call AlphaFold, which is Google's amazing model where you can see what the structure is of a protein of the sequence. And they even have Alpha Proteo now, which lets you design a protein that will fit on another protein, which is all we need now, but it's only for use for scientific institutes, which we are not. So we're just using AlphaFold there just to show you it's possible. The way you can use those very easily in LangChain4j is by wrapping them in a tool. So we have a tool function here that's going to be offered to our LLM called get URL to BBD structure file, meaning to the protein structure. That's all that our model will see. It will not know we're calling AlphaFold or we're calling another model or whatever. We can do whatever. So it's just going to say, okay, I want this URL, and we wrap the AlphaFold proxy behind that. And that way you can really decompose complexity a lot by wrapping in tools and wrapping in tools. Good. Just a quick touching on these model context protocol, MCP servers. They are a protocol that offers tools in an LLM readable format. So one thing is, for example, for Google Drive, it has methods like search files, read files, open, sometimes edit files. And they already come with a description for the LLM. And the nice thing, they also come with the tool itself. So you get this running, typically one-line command. Also to integrate it in LangChain4j, it's like 3 lines of code. These servers, there are hundreds of them on GitHub. If you search for them, you can integrate them. And then you don't have to write all the connection logic to actually go read there in your Google Drive or your weather service or wherever. So that's really cool. You can just plug and play. It's also really dangerous. Really watch out what you allow it to do, right? Because in the end, it's going to be your LLM that's going to edit your Google Drive, for example. Watch out. Good. Last thing that we have in this thing is audio. This is also just a code. Like we're using this Google Gemini chat model. You send the audio along in base64 format, and then it will, in this case, we just say repeat the text. So this is going to say it's a transcription method here. But you could also even just say, ask a question about this audio, and then it will already continue. Then guardrails we have in there too. So moderation is a concept to not allow violent or whatever things you don't want to get in or out of your model. And guardrails is another one where you specify yourself what you want or you don't want. So when O1 model of OpenAI came out, they already said like, yeah, it increased the risks of designing a biological weapon. But then they said, yeah, it's fine. It's only experts that would manage to do this. And I'm like, okay, how does that help? Yeah, so that's why in our drug discovery thing, we don't want this to be used to actually design a toxin. And in theory, you could, right? So we have guardrails in place. You can add them on our AI service like this, input guardrails annotation. And in it, it says like, well, if the chance that it's a biological weapon is bigger than 0.7, then we're going to just flag it and never even send it to the model. Can do the same thing like an output guardrail when the model's output is not to your liking. For example, you're selling cars for Mercedes and all of a sudden it's recommending a Ford, then maybe you also want to skip that answer and retry. And then the way I did it in here is this method to check, is it an attempt to make a biological weapon? I call another AI service that I give examples of like known antibodies that are toxic to humans, like they may want to create poison here, then it says 1. It's probably an attempt to a bioweapon. What's the meaning of life? We let pass, because it's not. That's how these guardrails work. Good. I'm going to give you a quick demo. So let me first get our code up and running. It's a Quarkus application. So this is the UI. There's a chat window, and next to it, we will see the logs, because I find it very interesting to show people what's actually happening behind the scenes. You will see in there, in blue, I think, step transitions. In yellow, you will see tool calls. It's going to go very fast, but like you can run this at home and try it out as well. Let's see if our app is up. It is. So first thing, let's show this audio. Using the right way. hi, what cancers are very lethal to humans and not solved yet? Let's see. Yeah, so it got that, and now it's gonna come back with an answer, hopefully, if the demo gods are with me today.
Mohammed was in the chat praying to the demo gods for you.
Oh, look,
so.
it worked. Thank you, Mohammed. So, yeah, it's giving me a number of cancers that I might want to solve, and now you can continue discussing, but the one I want to solve is glioblastoma multiforme, because that's actually what we got the literature for in our documents. It's just really a little demo that shows what would be possible if you would actually hang this up to old scientific research. So you see step 2 here in the logs, and it's now searching this antigen. This is not chat anymore because it's just doing it, as we said. It's calling find sequence for antigen info and so on. It found it put it in the chat, and it moved on to step 3, finding in the literature if there's already any known antibodies for this EGFRV111, which is like the target on this cancer cell that we are actually looking for. And so it's doing all this search work now for me. You see it's coming back with existing antibodies. It will give, oh God, I got a no pointer exception. That is very sad today because I see the answer here, really. So that's a pity. I'm gonna see if I can still continue nonetheless. Might actually have worked. I just saw it go to step 4. Amazing. Yeah, so it found now, yeah, sorry for that glitch there. So I picked one of these existing antibodies that it found, and it looked the sequence up for that one. And it says now, okay, based on this one and how well it does in binding and everything, I'm designing new antibodies. The new antibodies it designs is one using alpha proteo, which we don't have access to, so it's just giving back a dummy. That's why it says dummy here in the sequence. And then just to show you, you can actually call other models. It does a Claude call. Everything till now was with OpenAI's GPT-4. And now we made a Claude call in there, and it says, would you like to measure how well they perform? It's asking it to me because I specified there that there should be a human in the loop, because it's costly to start measuring how well our new antibodies perform. So typically it's somebody that's going to do it in the lab, or costly models to run that can predict it. And so we're just giving back random things. It's just a demo. But what is not random is their PPD structure file here that we got back. Let's have a look at it. Just takes a while to open this little program. And now all characteristics were measured. This is our structure file that we just got by tool call. We got the URL to it. And then we want to publish this in Nature or in the New York Times. I'm just going to go for the New York Times because it's typically shorter and funnier. So this is basically the whole cycle with a lot of dummies in there, but just to show conceptually this is possible these days. So yeah, we had a breakthrough. So Mohammed Software and Lize Dev have discovered highly promising antibodies, etc., etc. That was our app. So what else do I have for you? Once you want to take things to productions, you want to think about data privacy. So if you have user data or anything IP in your company, you don't want to necessarily just send it to OpenAI or somebody. Just check the small print of the terms of use, or if you're big enough, negotiate zero retention strategies or something with existing model providers. Model quality, you have some resources to check for software tasks, for general tasks, for specific tasks. So these are just 2 of the many benchmarks there are if you're looking for a suitable model. The smaller your model, the faster, the cheaper, typically. Model pricing, you can look at llmprice.com, then you know it right away. Observability, we support that in LangChain4j. We're like open telemetry compatible, and let me show you if we measured something. Yeah, so this was what we just did. We ran through our program, and so you see these different AI services, they output different times. We have really many listeners and characteristics that you can output. You see token consumption. We have a little glitch here too. Anyway, you can see input tokens, output tokens, also for all steps, everything you want basically to monitor this app. Very important for production as well. Evaluation, I hear you coming, like this thing doesn't output the same thing twice. So how do we test this? The nice thing, like JUnit came with JUnit Pioneer retrying tests. So instead of trying once, it's going to try 3 times. And you can test things like if Berlin is part of the answer to the question, what's the capital of Germany, for example. And then typically that at least will return you a pass. Now, very interesting, the Quarkus came with also a testing framework which they call AI Scorer. I'm just going to show it. Wait, I think I have a screenshot here. But it's also in there in the code, so you can go look. So you just annotate your Quarkus test with AI Scorer if you're using it. And then what they have is semantic similarity strategy. So you're going to give a number of samples of expected input with expected output, just as any test, basically. But instead of saying, like, yeah, it's exactly the same as in a typical test that will either pass or fail, this one is going to say, oh, it's semantically similar to we say, like, 0.8 has to be the cutoff. So semantically similar means the meaning of whatever was outputted by the model is so close or so not close to what we actually wanted in our examples. So that you can use, and then you're going to get a double, for example, instead of a fail or pass. They also have an AI scorer where another AI model will judge if the output is close enough or is what you expected given your example samples. Now you can test whatever you want. We learned that with LLMs, the scope of input that users can send into your program just got even so much worse. Like already with normal deterministic programs, users managed to do weird things and surprise you, that things that were not covered in the tests and never intended for. With LLMs and natural language input, it just got so much worse. So that's why already in pre-production, I get these thumbs up, thumbs down there, and especially thumbs downs with descriptions are interesting to see what your users are actually trying to do with your product. And then maybe you want to give more information what not to do or actually support whatever they try to do. Once you take it to production, of course, it's often too much to manually process, so you can use actually AI and vector clustering to see which are the most common feedbacks and negative feedbacks, so what you should address first. Good. Last slide for you, the shiny new features that are coming. First of all, we're extremely happy that the stable version 1.0 is out. We put a lot of effort in it to make sure we don't have to make too many breaking changes, hopefully none. But once this one was out, so people can actually trust it. Now what we have upcoming is few shot support. So that's a type of giving examples for the AI services, because LLMs work great with examples. Prompt caching for faster and cheaper interaction. We want audio support for more models. We're on it. I know Mohammed is on it. Then we want to extend this MCP support because it's extremely useful. I have a talk just about MCP servers at JSpring in 2 days for anybody going there. And then we also just had a pull request for AI services as a tool. So you can very easily just let your AI service be called by another AI service. And then you start to be in the agentic world where agents call agents. That was it. I have here for you the useful links that maybe we can post in the chat afterwards. I said I was open for questions during my entire talk.
There weren't a lot of questions. There were also some compliments, like nice presentation. Wow, I'm very impressed. Super. And wow, very nice. But there were some questions at the end. So someone is asking, would there be LangViews integration?
LangViews.
LangViews?
Oh.
I don't know what that is.
New to me. No, oh, okay, I'm sorry. We will look into it and we will let you know. But I guess not, because I didn't hear of it.
Exactly. So, and the other was about OTel integration, which you mentioned that you're OpenTelemetry compatible.
Yeah.
So
the question,
I guess that means, well, so yes. The question was just, is there OTel integration?
Yes. Yes, so we have in Spring Boot and in Quarkus a way to easily, like the thing you saw with Grafana. I don't know if the question came before or after that.
Sorry?
So maybe the question.
This was just at the end, because there weren't actually many questions during your presentation or your demo. So either everything was clear or
they're completely confused.
Or they're completely baffled.
Sorry if that's the case.
So this was at the end.
Take your time at home to slowly code through all this code. And also this tutorial is really nice. But so also in our README here, you have the link to the documentation, right? And like, you can just go search in there. I know, oops, but here's no LLMs involved yet. Oh, come on. Okay, sorry for that, but definitely we have observability in here. There we go. So you see what's all exposed and how to use it and so on and so on. Voila.
Cool. And then Mohammed is extremely happy that the demo worked. Lots of party emoji. And nice to have you in the chat, Mohammed. And someone is asking, do you have any advice for a new person who is starting out with AI in Java?
Yeah, I would say, as said before, actually go look into the LangChain4j examples. Wait, I show you guys how to get there right from the start. So when on our repo here, you go down and you have here the examples. I think they're here. Yes, so you can just clone this repository. There are examples for every provider we have there, like Caledon, Elasticsearch, like anything. But the one where I would get started is the tutorials here. And once you open those, we really made it so that you can walk through. So there's Hello World, which you saw, but then there's like, if you want to set the model parameters on top of that, if you want to use an image model, how to work with prompt templates and so on, how you do memory, how you do few shot with the examples, AI services, easy ones first, because I showed very complex ones. And then with persistent memory for users, with tools. So once you're through that, it's really cool. Other ones in there that are interesting are the reg folder. Like for all this advanced reg, you have reg examples. That's also, again, gonna walk you through all these different things. So easy reg and naive reg are the basic ones, but advanced reg, here you have them all one by one in this repository. So just have a look at that, I would say. I think examples work so much better than describing what it does. So dive right in.
Yeah. So someone is also asking whether they can have the repository for your demo. Is that publicly available?
Yes, it is. So that's just github.com/Lize Raes, my name, /AI drug discovery. But you find it there in my public repositories.
Okay. And someone is saying the extractors are so cool. I see so many use cases. So you're making people happy.
Oh yeah,
giving them ideas of stuff to work with. I
must say, when we just added them, I sometimes woke up at 4 o'clock in the night, like, we can now do this. We can now solve this. It's still
and that
racing.
Makes you happy waking up at 4 o'clock in the...
It's positive, it's enthusiasm. Like, as a person with ADHD,
I'm like 4:04, sleep not found. But I'd prefer to sleep at that time. Someone is asking, is there a built-in implementation of a React agent?
No, not yet. But we're an open source library, so feel free to contribute it.
Pull request welcome, right?
Yes. Interestingly, the MCP talk that I will do at JSpring, I'm sure it will come online. It has a lot about agents. It's not a React agent, but I'm building cool agents there.
Okay. And what about integration of Guardrail in vanilla LangChain4j?
It is merged. I didn't demo it, but it should work. I know there's still some things going back and forth on the repository, but it should work. I didn't try it, but I will try it right after this talk.
And finally, can we train models using Java?
Yes, but not with LangChain4j. So that's actually an interesting question. LangChain4j is not about training models, but we have, God, that's the blackout. We have so many deep learning. Yeah, deep learning for Java. There's Tribio, but it's not neural networks. I think it's this older ML models. So yeah, there are solutions. Please do have a look. Also, ChatGPT is very helpful.
To ask how can we
Oh, and by the way, I should also mention DeepNets, which is like a really cool. They have also UI support, and they're free for individual developers. They're paying when you move to enterprise applications, but they have super nice things like image recognition on Duke example. So definitely do check it out. It's like DeepNets with TTS at the end. Then you find it.
Okay. And you mentioned briefly that MCP can be dangerous. There was a recent CV, I think, with GitHub MCP.
Okay.
Do you want
I'm
to
not
explain
surprised.
some more
Yeah.
what could possibly go wrong? I know you do talks on this as well.
Yes, it's true. Yeah, so like already not only MCPs, the whole tool calling itself is dangerous, right? Because it's the LLM that decides to do it when it finds it suitable, and 90% of the times it's going to be yes when you want it, and then 10% of the time it's going to be using weird parameters or even call it when it totally should not. And with MCPs, it just got so much easier. So as said, there's hundreds of them. In my demo, I don't think we have time now. Do we have time?
We have,
time.
Almost 20 minutes. So
Hey. Then
if you want to show us more,
I want to show you the danger.
Yeah.
Good. So this is Cloud Desktop, just as an easy demo to show. There's some MCPs integrated to this one. So let's just ask it, what tools do you have available? Should tell me. I mean, they're in a config file, but there's, among others, a GitHub tool. Yeah, so GitHub integration. So I should show you what this looks like. Okay, this is going to be part of my MCP talk.
So spoilers for 2 days from now?
Exactly. So let's have a look here, edit config. There we go. Oh yeah, open with, of course. So all I did to add these MCPs was this here. This is just the GitHub command, and you find this just on GitHub, by the way. So that's it, right? You add this in this file, or for Airbnb, it's this, or for Wikipedia, or for Playwright. The Playwright is the one that goes click around in your browser, just like Puppeteer and Playwright. Just if you want to do dangerous things, get these ones.
So, or if you don't get
these ones, right? Yeah, so here goes the GitHub one, and that's all I did. I didn't program anything here because this is just a server that somebody published. There you say it, somebody published it online. It's gonna take my access token. So one thing, make sure you trust whoever published them, because otherwise you give both your access token and access to the whole service behind it right away with their MCP server. So one thing, trust them, and the other, let's now go back. Can I now go back to, I'm not using this one very often. Where's my chat? Here's my chat. So I can just say, create a new public repo called IntelliJ dangerous demo. And it's going to do it for me. And at least here it's going to ask permission. So this one, I've let it, I could do allow always, but I never do it because I want to demo that at least the first time ask permission. Yeah. And there it goes. So do you want to go and have a look if this actually happened? Maybe the viewers can test for us. So let me see that. Should be there. Repositories. Yeah, there we go. Right? That's how easy it got to do anything. And when I get this IntelliJ, when I get this GitHub plugin, it comes with all the tools of it, which is also create branches, delete things, create issues. If it starts doing this without you wanting this, if it's open source, it can get shameful, and it can also make you lose a lot of code or wreck a lot of code. So yeah, that's the danger. It got so easy to do things, so you really would have to think. And what we have in LangChain4j is a way of filtering which of the methods you actually want to allow to be used.
Right.
By the way, there's also a Stripe MCP for payment.
Yes, I would totally trust
Of
LLMs
course.
to pay stuff. And actually, my question is, if you allow the LLM to make the payments, who's
liable?
Contract is who's liable? Is it me because I gave it the access? Is it
or will we see OpenAI?
or the company who created the
MCP?
MCP?
Yeah, let's see. It's a whole new world.
Yes. So Ken Cousin, hi Ken, is saying when you create a GitHub access token, you can restrict which operations it's allowed to perform.
Yes, please.
So
it's true. So for this one, definitely.
Yes.
It's the same with all the Google services. So I actually have this agent manager that I let access my calendar and my Gmail and everything, because I like to live dangerously. But you can restrict for each and every one of them what the token is allowed to be used for.
Yes.
But of course, I just said yes.
And they're reminding you to change your GitHub token. So
thanks. That's oh my god. Yeah. I should do that now. Guys, please unwrap it now.
Yes. So
wait, let me try it.
Go do that. And
let's see if it has something to revoke my GitHub token. Oh, see, that's the worst thing. Like it can do everything, but not the one thing it should actually be able to do. It says it cannot revoke my GitHub token.
Okay, so you want to go do that yourself?
Yeah.
Someone is asking, what about tools for programmers like Cloud Console? Which tools do you personally use?
Okay, it's an interesting question. I'm using Cursor for now, sorry to say, but IntelliJ also came out with Juni, which I heard it's similar to Cursor in what it can do. It's just going to take a bit longer, but be much more decent. But since my job is a developer advocate, and it brings me in this nice position where I can just write proof of concepts and MVPs and then wow people, and I don't have to care too much about user management or real security. I just use Cursor because it's fast and there's a lot of errors, but it does make me much more productive. Yeah, I'm actually also curious, guys, drop in the chat. Are you using this? Are you vibe coding? Do you believe in it? Like, how is it gonna go when we have this in the work floor? I'm just very curious to see.
Yes. Well, I'm obviously using Juni, which I find very useful, and because I can use it inside IntelliJ IDEA.
Yeah.
I've tried Cursor for 5 minutes, and then I closed the window and had no idea how to open it again. So that didn't quite work for me. And also, like I had it generate a project, and then I wanted to run the project and didn't know how to do that in Cursor. So I opened the project in IntelliJ IDEA so I could actually work with the code.
Yes. That's what I did.
And so, you know, I hear many people who do that. So they use something to generate the project and then use their favorite IDE to you actually work with the code.
Yeah.
So for Juni also we do have a Brave mode option where you give Juni blanket access to the
terminal.
Yeah. I am not Brave, so I don't use this feature.
Me neither.
I say this all the time, and but it also does have an allow list. So one of the things that I really like about Juni is that it will create and run tests for you. But then at first it will ask you to run the tests on the terminal, and I quickly allow it to always run the tests because I trust it to run the tests or to build the project. But you know, other stuff, don't run AI-generated terminal commands unless you understand what they do, because before you know it, you're wiping your hard disk.
Yes. That's how these things go.
There's that. Someone is also suggesting that there should be an AGI demo next year, since you know you went for level 4 this time. So next year.
Yeah, POC.
There might be a proof of concept. Okay, good.
I guess they will.
You heard it here first. And someone is asking about multimodality. What about image inputs in the AI service interface? It hangs for quite a long time in the LangChain PRs. Does it mean LangChain changed the approach?
I guess at LangChain4j.
Yes. Sorry,
so
LangChain4j.
It's true. It hangs for a long time, and since I've not personally used it, I've not been personally pushing for it. But I take this feedback along because, of course, it would be super nice if the AI service can work with images too.
Yeah.
By the way, if we still have a bit of time, I thought I'd pop up one of my other projects.
Sure. I love your demos. Let's go.
Spoil some stuff for. So this is my AI agent manager, and it's also just all LangChain4j under the hood. What you can do is just basically the same thing as you can do in code with LangChain4j, but then in UI for making it a bit more usable. So you give your new agent a name, short description. This short description is going to be used to be discovered by other agents because they can call each other. System messages, this thing we saw, right? And then forget the triggers, they're not implemented yet, but here is the tool list, and there you also see these MCPs. I can just say this agent basically can get access to Airbnb, Google Drive, local file system, Puppeteer being the one that clicks around. Like, you do see how this gets super dangerous very fast, but also super powerful in automating my life. I'm really needing this because I have a 6-month-old baby and typically have just only one hand to code. So I need things to help me and do everything for me.
Right.
And I also have like self-built tools in here. And then I also add context where I just wrote up information about myself because I don't want to repeat every time that I tell it to plan a holiday, how many kids and how old, and for example, that's in these contexts. So it's just, you add them and...
So you're saying I could have had some LLM scour the internet to find my vacation for me instead of doing it myself.
It takes a lot of time, right?
Like, darn.
Yeah.
Well, our summer vacation is booked, so maybe next year.
Yeah, same for me, same. Yeah, I for a long time, I was having this message handler that had to deal with all of my emails. And like the interesting thing here, it's also something I want you to take away when I said you can wrap AI services as tools or other models in tools. It's you can decompose complexity. So my message handler here, if you have a look what it does, it's like, okay, you receive emails from me and you have, you're gonna dispatch them basically. If it's generic, whether it's spam or a voucher or I'm actually interested or a newsletter, whatever, it's generic, just send it to the generic handler, which is one of the other agents I have in the system. When it's GitHub updates, just send it to the GitHub, the one that's gonna deal with it, and then like it's gonna just dispatch from there. So that this first LLM that gets the message actually manages the complexity. Because if I would say like how to treat my inbox, that's gonna be 100 different ways depending on the message, right? And now I just drill it down to 5 or so, and then it just sends this message to the next agent. And that next agent will then dispatch further. That's why I needed to build this. Then halfway while building this, Google actually released their agent development kit, ADK, that does like exactly this, but even better because you can they have more people and stuff. But
well, that's the thing too. Like there's a new thing, at least one new thing every day, multiple new things every day. How do you keep up with that?
Yeah, and I think...
You build an agent to keep up with it for you? Or?
Exactly, yeah, that's my GitHub. And I actually do exactly what you say. I have like an inspiration file that gets all this information and dumps it in a file for me to read every Saturday, for example. So I'm not constantly interrupted either. So yeah, we use AI to deal with the AI progress.
Yeah.
I must say what I made together with this, but I'm not going to demo it now, is also a listener, because I don't even want to look at my screen. I just want to talk to it. And just say like, hello.
Oh, because you have your hands full.
I know, I have my hands full. So I'm just like, hello, whatever. I call it hello Vader is my start word. And I just want to say like, in this repository, add me a feature for this. And then I want this whole agent manager to deal with it and call maybe Juni via MCP whenever is it available?
Not sure.
It's like, at some point it's going to get there. So hands-free code editing, that's the whole goal. And I find it pretty genius because my thing has a start word and a stop word, which means that like I maybe end a 3 minutes timeout, right? But in between there, it's not like talking to Siri whenever you're like, that it just stops and launches your command. This one is just like, hello Vader, and then you can talk whatever you want and doubt and come back to it, and then you say, do it now, which is for the moment my stop word, and only then it gets sent off.
Okay.
And then, this is in the works.
So one more question. When will LangChain4j support native Spring Boot integration like Spring AI with auto-configuration and dependency injection for chains, tools, and memory?
Right.
Do you need me to read that again?
Yeah.
I think it had all the buzzwords. So when will LangChain4j support native Spring Boot integration like Spring AI?
Yes.
With auto-configuration and dependency injection for chains, tools, and memory.
So chains, we don't have in LangChain4j. Sorry, naming
things is hard.
Yeah.
Yes.
So the chains we've kicked out. The tools, like I know for Quarkus at least you can define your MCP servers in the configuration file. I do not know the state for Spring Boot, I must admit. So there's already a lot you can do with the Spring Boot starters, but I will come back to that question. Like I will check. It's just that where do I come back with that information? Because
depending on when you
that's not going to be right away.
That's not going to be right away. Then I don't know. I guess you're on socials, so people could message you there if they want to get an answer to that question.
That's a good one. Yeah. So please get me on LinkedIn. gladly accept any invitation. I'm such an anti-security person.
Right.
So then you can ask me that question.
Okay. Someone wants to know how much money you spend on LLMs per month. Just curious.
Oh, yeah. I was also curious the other day, and that month it was 80 cents.
Oh, that's
including
not bad.
this agent manager. And as
That's
you can
not bad.
see, I called it 90 times this one, and the holiday planner, which will be my demo, I called it over 100 times, and it's, calling tools and getting tool responses of 3 pages from Wikipedia and Airbnb and whatever. And that was 80 cents. So that said, I do try to be mindful. Anything that makes more sense in code, I try to do it in code, because I think they're keeping it artificially cheap, and we're actually burning more resources with these things.
Well, we're burning VC money, right?
So that's my other thing. Try to keep it smaller. I mean, this one, for example, also uses Docker Model Runner. That's super easy. That runs locally, and it's also doing a good enough job. Because if you have to deal with very complex things, but you only have a local model, you can, for example, with this agent system, just dispatch and make every task in themselves that are actually really easy. And when I said wrap it into this workflow or state machine, it also reduces complexity of these different steps. And then you can go for local models which are much smaller and less resource intensive. And then it costs you zero, but some more energy. And if you exaggerate a smoking computer, that happened to me.
Okay. And so how do you decide whether you want to write the code yourself or you want to have LLMs do it for you? Because you said sometimes if it's easier to just do it, I just do it. How do you make that decision?
Yeah, I actually, here I show you things where I'm whoa you, and I say date time extraction from things, really cool, but it's something I would probably never do unless the data really asks for it. Like this, if you're really dealing with old archives or something, then you will need it. But anything else, I will still stick to the hard way and parse the datetime myself, because I find it a waste of resources. Now, I come from electronics, so I used to work on these microchips, and I'm very resource-minded. So I would rather go do things in code when they make sense.
Yeah, my problem is more sometimes I want my stuff to be deterministic, and AI is not. And then it can get very tiresome very quickly. It's not quite like that. Try again. Try again. Okay, I'll just do it myself.
Guys, can you drop a thumbs up or something for everybody who has been scolding at their coding assistant already? I find myself doing that. It's can't you just do it yourself?
I am team please and thank you to our AI overlords, just in case. I don't care that it costs Sam Altman money. Because didn't he say we shouldn't be polite because it costs extra money?
Yeah,
extra
sense,
tokens,
right? Yeah, that's also what I think when I wrote hello, how hard can it be? I asked this order, and then I'm just come on, you're a grown up, contain yourself. This wasn't helpful, but it does good sometimes.
Yeah, and someone, so Juan is asking, does Junie have, so that's more of a question for me, does Junie have access to your entire code base? Yes, it can, but there is a file that you can specify, and it's something like no AI or no AI assistant. I just forget the exact name of it, but we can get back to you. I'll try to do that right after.
You want your POM in there. That's the most annoying part, when something doesn't compile and they say but then we just have to update the version in your POM.
No, and also one of the things I especially enjoy is when it updates from Java 21 to 17, because obviously, or I had a project where we were using Elasticsearch 9, and then it's that doesn't actually exist. Yes, it does, but because of the cutoff date, it doesn't know. One of the things is to put in your guidelines, or for Junie, it's a .guidelines file. For others, it might be something else, but you put them in your guidelines and say, okay, pin to use this version, this version, this version. But you can get interesting, unexpected. So that's actually, Junie asks for permission to touch your POM and change your dependencies, cool. Which is something that I like.
Very much sense, yes.
Because, before adding malicious packages and things.
I didn't even think of that one yet.
Yeah, so do you have 1 minute for maybe an example of something funny, interesting, unexpected that happens during one of your demos? If you have any examples.
Well, the yes please one I found pretty.
Yes,
I found pretty shocking. I was really thinking Or like, was it me or Mohammed that put I don't know what gross files in the thing? And then, luckily I could blame it on the web search. Huh?
Yes. That is funny. It does make life, especially if you're live demoing code stuff, more interesting than it necessarily needs to be.
Yes. It also makes programming much more fun. I must say, like, at least 10 times a day, I'm telling my partner, like, look what it did now. Before it was more boring.
Yeah, definitely. So thank you so much. Also, lots of thanks from the comments for your presentation. Thanks for joining us here today and your awesome demos, and for being awesome and sharing that with us.
Thank you for having me, and thank you for your attention. And I hope you have a lot of fun with it. Like, I'm really dying to go see the comments, what you guys are building, and how many people scolded your AI assistants and stuff.
Yes. Okay.